Okay, can. So done. Let's check the answer. Okay, so that is your sulfuric acid, and then your part sulfuric acid in excess, because your sulfuric acid you have 0.0375. Okay, but then your this sodium hydroxide you only have 0.025. Okay, so by right I need only to react with 0.025. I will need 0.0125. So your sulfuric acid is obviously in excess. Okay, so that's how you determine sulfuric acid is in excess for this question. Okay, any problem? Can? Good. Okay, let's carry on. Find the mass of sodium sulfate form. Okay, so remember, once we have determined who is the excess reagent, right, we don't care who is the excess reagent now. Oh, the irony is like that. When you are the limiting one, right, not enough reagent, we are more interested. Okay, life is like that one. Okay, when you have very little of something, then you treasure it a lot. Okay, when you have a lot of it, you say, yeah, so much food on the table. Okay, you don't like bread. Then suddenly you don't have bread for a long time. Because this CB cannot go out, right? Then you suddenly love to eat bread. Okay, no link. Okay, try to find some link. Okay, so now can we confirm who is the limiting reagent? Sulfuric acid is the excess, so sodium hydroxide is the limiting reagent, right? So I'm interested in X. So the number of moles of your sodium sulfate must be linked to the number of moles of the limiting reagent. 2 moles will give you 1 mole of sodium sulfate. So number of moles of sodium sulfate is X over 2. Correct? Oh, don't make a mistake here, not 2X. Okay, then after that we can find mass. So what's the mass? You just apply the formula, multiply by the MR of your sodium sulfate, which is inside your periodic table. Okay, you extract out your MR to confirm. 1 minute, then we check answer. Question. You know why I didn't use sulfuric acid? Excess reagent. Excess reagent, we don't care. It doesn't affect your number of moles of product. Also, we straight away take the number of moles of your sodium hydroxide divided by 2. 2 moles give you 1 mole. So 1 mole give you half mole. So half X. 0.0025, I think. Divided by 2. So this is what you do. Then you form your 0.0125. Then you can calculate out is 0.178. Okay, can you check your calculators? Make sure all of you can get this answer. Okay, shall we? Can? Clarice? Okay, yeah. Can you all put a thumbs up, can it? Now you all know these few days the webinar very crazy. I watch some webinar, then the trainer always say, if you get the answer, smash the yes button. Then one whole row of people smash the yes button. A bit one bonkers already. Okay. I think stay at home too long is like that. Maybe you can try that. Okay, can you all type in the chat box if you have no problem, you just reply, say yes, no problem. Okay, no problem. No problem, we go on to the next question. Okay, or you can put a thumbs up. Very good, Shamil, I can see your thumbs up. Excellent. Yeah, I can see the chat box. Okay. Yes, thank you very much. Okay, thanks. Okay, come, let's go back to the question paper. Next part, titration question. This part you need to do on the Foolscap paper. If you have, I think the space here is too small. Okay, so I will run through with all of you, because this is usually the last part of your practical paper. Remember your practical paper, after you finish all the titration, blah, 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 then towards the end, you ask you to find concentration of your sodium hydroxide, or concentration of your this acid and so on. Okay, question 1, you can see you have hydrochloric acid, you need sodium hydroxide. What is the concentration? Easy, right? The famous formula I teach to 3 of you last week. Sodium hydroxide, and then your HCl 1:1 mole. Can we solve the concentration of your sodium hydroxide? Can, right? Because the rest are all known. I know this, I also know this. 3 of the factors here are known inside this formula. confirm I can solve concentration of sodium hydroxide. Okay, very fast. Okay, so punch your calculator key and then you can solve it. Okay, so same thing for the second question. Second question over here, you are told that it reacts completely with sulfuric acid, calculate the concentration. So I'm going to use a formula again, CV NaOH over your CV H2SO4. Okay, what's the problem here? You must remember it's 2 over 1 here. Oh, if you cannot remember, write the equation out. Don't make mistake. Once you insert the wrong figure or you rotate the number wrongly, instead of 2, 1, you put 1, 2, sorry. The formula is as good as lousy formula for you. Oh, so if you're not sure, write the equation out, okay? But if you can see that it's a dibasic, right? You can see dibasic here, you need only 2 moles of sodium hydroxide, react with 1 mole of the sulfuric acid, right? So 2 over 1, can I therefore solve the concentration of your H2SO4? Can okay, press your calculator and then we solve together. Okay, that is for question 1 and question 2. Okay, let's check the answer. If you have done everything correctly, of course, this is a long method. You can see the long method over here, you require you to do conversion. Okay, conversion, there's nothing wrong, like what I told you, okay, but conversion are likely to make more careless mistake if you're not careful, or your calculator happen you press 1 0 short, then no way to check that you can get the correct answer. Okay, so if you do the C1V1 over C2 CV method, right, just now the formula I shared with you, you can solve it easily for 1 and 2. Okay, so you must remember for the second one, the mole ratio is 2:1. Okay, 2:1. So your sulfuric acid, you need only half the number of moles. Okay, can? Or can then you can move on to question 3 first. Question 3, done. Question 1 and 2, no problem. Okay, now question 3. Okay, question 3, you must remember, even if it's not structured in this manner, whenever you use a calculation for mole concept, you cannot use in gram per dm cube. We never relate gram ratio. Okay, so your choice over here, right, is to make sure that you use mole conversion to mole first before you can proceed to calculate. Okay, so A and B, can we do that? What is the meaning of number of moles of sodium hydroxide in 1 dm cube of P? So from here, can you see that is dm cube below? So just convert 3.8 over the MR of P. What is P? Sodium hydroxide. Okay, you get answer X. Okay, so next we also can do what is the number of moles of acid in 1 dm cube of the Q. Okay, over here you cannot just take because you do not know which is whether it's HCl or nitric acid. You must make use of this part. Again, you deploy your C1V1. Your CV over CV equals to 1 over 1. Okay, you try out. So if you have done that, right, you can get the concentration of your Q already, right? Can we find the molar mass of your Q, the acid in Q? Can, right? Because once you know the number of moles of acid in this Q, right, you also know the mass. I can relate for part C. Molar mass can be obtained when you know the mole, and from part B, you can solve the number of moles, and you also have mass. Can I find molar mass? Possible, right? Can be done. Once you have done that, right, you can identify whether it's nitric acid or hydrochloric acid. Oh, so this is a very good question. You can put a 2-star there. Indirect way of solving. Okay. Question. Okay. Yes. Sorry. Who sent a message? Have not sent. Okay. I will remind Mr. Lai. I will remind him. I will remind him. I think he's too busy. No problem, no problem. Okay. Maybe later you all can type inside the chat box, not the chat box, the WhatsApp group also. So because the admin from A Hive will also be looking at the responses. Oh, so they will also do that. Okay. And okay, 3A, 3B. Done. You solve, you should get this. Or you can use C1, V1. You don't need to follow this. You will use CVNaOH over your CV Q, right? That is 1/1 because they are both monobasic. Oh, so you can use C1, V1. This one, this formula. You can also get this answer because it's mole per dm cube. Okay, after which you can get the mass divided by the number of moles, you get your molar mass, 63.0. Okay, once you obtain that, then you just observe comparing the HCl and your nitric acid. Nitric acid happen to be 63. You take on the data booklet. The hydrochloric acid is 36.5. So it cannot be nitric acid. It should be, so I mean it cannot be hydrochloric acid. It should be nitric acid. Okay, no problem. This question okay? Shall we proceed? Okay, let's come on to question 4. I mean question 5. Okay. Question 4 first. Question 4, you have this solution containing 12.2 gram DNQ of carbonate. Can you see? It's always like that. If they want to test you in this form, right, they will give you in gram per DNQ. Okay, so we are going to follow the same idea as on top. Okay, 3.65 of hydrochloric acid. Okay, so they ask you to calculate the concentration of hydrogen chloride, and then what is the concentration of carbonate in your sulfur? I mean S. Okay, this is S, right? Go the carbonate. Okay, you observe very carefully. Okay, so this question I'm going to teach you a secret trick. Can you see this? Can you see this? 有看到吗？ What's so special? You can see this X2CO3, right? X2CO3 means what? X2 plus CO3 2 minus, or is it X plus CO3 2 minus? This one, right? This scenario, right? In order to get this formula, you know where I'm coming from. Why? Why I want to train you this way? This formula, right, tell me something very interesting. X is in group 1. 对吗? X is in group 1. Why? Because every time when students check paper, right, I ask them what are you checking? Check the working. Check the working means what? Do from A, B, C, D all over again. See whether got any careless missing. Don't need. Because part D, they ask you to suggest an identity for matter X. So mentally, when I'm doing this question, right, when I'm moving through this question, what am I thinking at the back of my mind? What am I thinking at the back of my mind? No lah, not the lunch later lah, okay? I'm thinking in my mind, right, when I reach step D, I better get a group 1 as my answer. Correct or not? You think about it. Can you see why when you see a question, do you see things like that? That is very important. Mentally, when I approach this question, right, doing all the number of moles, calculate all the concentration, blah, 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 which is similar to question 3. But what am I doing? At the end of this question, right, if my method X is not from group 1, what does that tell me? Something is wrong with my calculation. That is how we check paper, check question. Oh, correct or not? Logical, right? You see logical or not? Unless your teacher anyhow said your teacher who said this paper anyhow dump the X2CO3, then end up your answer at the end, your method is group 2. Something is wrong. Your method confirm must be group 1. Okay, so if you have done your question already, check your identity of the method X based on the atomic mass. Is it group 1? Yes, you are correct. Wrong, something wrong with A and B. Confirm. You understand what I'm talking about? Understand? You all get the idea. You all get the idea because you see, the question is dead. I'm sharing with you my thinking process. How I think when I look at the question. I extract some valuable information that prepare my mind. Like sound like a bit of kung fu show like that. Okay. It prepare my mind. Before I reach the last step, I'm looking out for a group 1. If I calculate at the end, right, my method X is not group 1, I am in trouble. Something is wrong. Okay, that allow me to check my answer. Oh, can good. So I share with you this little tip to handle more questions, especially with this kind. Okay, so let's take a look. So what will we do? First step, very standard, calculate concentration. We can calculate 0.1 given to us. Write the equation here. Okay, X2CO3, because I know you're not familiar with the mole ratio. Okay, so 1:2. If you write out something like sodium like that, like sodium carbonate. Okay, so if you want, you use a formula which I taught you also can to solve this part. You can also use CV X2CO3, right, over CV HCl, that is 1/2. The other way around, because now your carbonate require 1:2 moles to react. Not 2:1, it's 1:2, okay? So you solve, you should be able to get the concentration 0.0885. You all try this formula. CV instead. Okay, you all have this already. Later you all one can watch the recording again. So but use this formula to convince yourself that it works. Convince yourself that it's faster and it works to find this. The one on top, the formula on top. Okay. Then after that, I can go on to the next step. I'm given the mass. Can I find the MR of this carbonate? Of course. Divide by 0.0855. The mass 12.2 divided by 0.0855. I should be able to get 138. So we are very near already to the answer. Part D, we want to find out the atomic mass of the metal X, right? I let it be X. Make it simple. So I sum up the atomic mass. It should be 138 as well. Your X is 39. Metal X is potassium. Where is potassium? Where is potassium? Group 1. I am very sure that I did not make any careless mistake in front. Correct? Can you see how powerful when you know what you are looking out for? When you make a mistake, right? Careless mistake, you know. Or the question will alert you. Let's say you find, hey, metal X is magnesium. Then you ask yourself this question. How can it be magnesium when the formula for the carbonate is X2CO3? If it's magnesium, the formula should be XCO3 and not X2CO3, right? So that's why we are very sure that we are looking at a correct answer here. When we reach this step, it's potassium. So if you solve, can they give you lithium? Yes, lithium is in where? Group 1. Can they give you rubidium? Yes, all these are in group 1. Cesium, group 1. So don't be surprised. Let's say you find the answer, right? Then you realize you have other group 1 metals which are not very familiar to you, but can they be the answer? The answer is yes. According to the reasoning that we had earlier, the formula is X2CO3. Beautiful, right? This question, isn't it beautiful? No. Hey, you all don't sian leh. Come. Is it beautiful? Smash the chat button if you find that it's beautiful. Clarice, are you there with me? Anna, do you find the question good? Do you find this question very good? The reasoning behind it, very good, Yeah, I can sense that you are also very excited with the question. Fang Ling, how about you? Yeah, good Okay only this question, okay lah. I ask your school teacher to set a harder one for you. Okay, can next one, question 5. Question 5 is sodium thiosulfate, okay, with an oxidizing agent containing 3.6 gram per dm³ of KXO3. You are told that it requires certain volume for reaction, and then 1 mole react with 6 moles of sodium thiosulfate. So first calculate the concentration, okay, relative molecular mass, and then the relative atomic mass of X. Okay, again, right? Let me ask you, this thing, what does it remind you of? What does this remind you of? Or remind you of something, right? So you can see this XO3, right? XO3K, XO3. Of course, you will learn under your redox chapter, right? You must recognize this X likely to be what? Iodine. Because this is K plus and IO3 minus. I'm giving you some info first before we tackle the question. Okay, so can you see? That's why when they join together is KiO3. Your X is I. Maybe or chlorine also, can be chlorine also. So can be one of the halogens. Group 7. Okay, later we confirm. So is it group 7? So question at the back of our mind, is it group 7? Okay, so later we check the atomic mass of X. We can roughly tell. Okay, come, let's take a look at the solving. So first step, very standard. We've done it so many times. Number of moles of BA1, number of moles of BA2. So you can solve it. So you get 0.0168. You can also use the relationship I teach you, C1V1 over C2V2, A1 over 6. Okay, so you can also do that because you are told that 1 mole requires 6 mole. Can you see? 1 mole of the oxidizing reagent react with 6 moles of sodium thiosulfate. Sodium thiosulfate is BA1. So from here, right, I can come out with the relationship. Your CV of your BA1 over your CV of your BA2. How many moles? 1 react with 6. 1 react with 6 is 6 over 1. Look carefully at how you write, okay? If you write wrongly, then you will end up with the wrong answer. This is what this line is trying to tell us. Sodium thiosulfate is BA1. So when I write BA1 on top, is 6 on top, not 6 below. Okay, so you use this formula, try to solve instead of working it through the long way, you can also get the answer. Okay, 0.0168. Can you try later using my method also, other than this, the longer way of solving it, or a lot of conversion here. Okay, right, so B, you solve it earlier. You have the number of moles, you have the mass. I can find the relative formula mass of XO3 minus is 214. Okay, I want to draw your attention why they use formula mass. This chap is ionic compound. Okay, so in exam, let's say they have no restriction, right? The question paper never asks for formula mass. You should use molar mass. A very clean cut way of referring to the formula mass or molecular mass. Don't worry about whether it's covalent or whether it's ionic. But this question cannot. This question, you can see that the question paper asks you calculate relative formula mass. Okay, so we do that. You will be able to obtain 214. Okay, can we therefore solve for X? So you solve it. Can you see? X is 127. Can you find under group 7 who is 127? Periodic table 127，谁来的 ？Iodine。correct not? Powerful, right? I haven't reached the answer. I already know the answer. Why? Because of years of training. Correct not? Years of training. I know it sounds a bit like a kung fu show. Okay, but it's like that. Okay, so when I see a question, right, I was looking not just at the structure of the question. I know they should ask me to do the same thing, calculate number of moles of this, calculate number of moles of B, then find the atomic mass and so on, okay? But the important thing is that I need three of you to understand when the approach that I take. When I look at a question, I observe carefully, right? I notice the formula is KXO3. It reminded me of that reducing agent IO3 minus, over here, that IO3 minus, can you see? So that's why I roughly guess that this fella is iodine. Of course, it can also be chlorine, can also be bromine, can be one of them, but this is a more common oxidizing agent. Okay, so therefore you will know that we expect it to be one of the halogen. And then when my answer come out, I'm very happy, 127, I'm very happy. Because it's iodine, it confirmed what I suspected initially. Therefore, I can, when I run out of time for checking during exam, I don't need to check this question. I'm sure it's correct. Cannot be so coincidental that I get x equals to 127 and not other values. Okay, 6. Let's go on to question 6. Last two, then after that we go on to acid bases already. Okay, question 6. Again, you are given potassium manganate, and then the other one is hydrogen peroxide. You all know hydrogen peroxide in your lab always keep inside this cloth. They will have this like bird cage like that. A lot of people describe how come your lab got bird cage, because hydrogen peroxide is very light sensitive. Okay, it's always kept inside a brown bottle. Okay, so because it will decompose very easily to form oxygen and hydrogen gas. Okay, so I think you have seen hydrogen peroxide before inside the lab, oxygen and water, I mean. So you will have the purple color solution that you see in the lab is potassium manganate, is an oxidizing agent. Okay, so you must recognize these two. Okay, oxidizing agent over here. So this hydrogen peroxide is a reducing agent. Okay, this is a symbol for reducing. Okay, so same thing, we go to calculate Ba4 concentration and then followed by hydrogen peroxide. So I will show you Ba4 is Cv, you all try this way, CvBa4 over CvBa3. Okay, what did the question tell me? Ba4 is 2 moles of potassium manganate react with 5 moles of hydrogen peroxide, right? So 2 over 5. You all try this way, I think faster. Can you see a calculator? You just have to key in one unknown to solve. Which one? You need to solve CBA4. Reshuffle, sub in the rest of the values into this equation here. Okay, then you can solve for me 6A. Give it 1 minute first. Press your calculator, because the answers given to you later, right, is the longer method. So, but I want you all to appreciate how beautiful this formula is. Okay, especially during MCQ, you can just place all the value in, you solve answer the question already. Okay, can? Okay, so this is a long way to do it. Can you see? Honestly, for practice, I don't mind you all do this. Okay, but step by step, push through. Okay, but then you must understand in time of exam, you probably need more time for other MCQ or other structured question. So you feel free to deploy the formula C1B1. Okay, so you solve it, you should get 0.0538 mole per dm cube. All right, then after that, you want to find the concentration in gram per dm cube. That is simple, right? Take the number of moles multiplied by the MR. This is the MR of your H2O2. Okay, solve 1.83 gram. Hey, Anna, good, happy? And see the light at the end of the tunnel. Last question, come, question 7. Okay, so you are told that this is given by this formula. Then you are given concentration of Ba5, and you're also given concentration of Ba6, which is hydrochloric acid. You are told that they require so much of Ba5 to react with Ba6. They calculate number of moles of BA6 represented in the required amount, volume of BA6. Okay, so BA6, you have your volume of concentration, right? So you have your concentration, which is 0.1, this BA6. Then you are given 17.2. So this part should be very easy, right? CV, you can solve it. Then BA5, you also have the volume, okay, but you don't have the concentration. So how? You can use C1V1, no? The CV and the CV relationship, right? So that will give you 1:1, right? Number of moles of BA5. So this is your, sorry, this one don't use this one first. You know why? Because you have the concentration here. I box out 0.04. So I can also solve part B also. After we have done that, right, we can relate the two mole ratio. I think you can solve this already. BA6 to BA5. Oh, so let's see. So 7A solve. And then your BA5, you do the same thing, you solve it, and then you relate the number of moles, you get 2. Huh? Your N equals to 2. Correct? In order to be BA6 to BA5 is 2. That means you need 2 moles of HCl to go and neutralize this base. The only reason is because in the formula of this base is must be 2. Oh, so a bit of reverse engineering you must work out. If let's say the question asks you determine the value of N, instead of asking you for this fraction, okay, it's possible for them to test you in this manner. Okay, so if you look at the question, or let's go back to the question paper first. Can you see MOHN? MOHN. So if N equals to 2, according to part C, right? Part B, your M, right, must be OH2. In order to react with 2 moles of HCl. Can you see the relationship? Blah, 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 the salt plus the water. Can you tell me which group M is in? Let's say the question asks you, instead of doing C, they don't ask you for C, right? They ask you which group M is in. What do you think is the answer? Which group M is in? M is in. Oh, you must observe, if N equals to 2, then you get this formula, right? So it's M2 plus and OH minus, isn't it? So therefore, my M is group 2 plus 2. Oh, so what is the possible identity for M? You can give anyone, magnesium, barium, any of the group 2. Oh, you can see the question can take a twist, can take a turn suddenly to ask you identify M. Then you all cannot look at the calculation and say, oh, I managed to find the fraction between number of moles of BA6, number of moles of BA6 to BA5. That is 2. Then after that, the next question they ask you identify M. Then you all, how? You only know N, but you know N, you can know M. Right? Correct or not? You know N, you know M. That's why it's M and N. M and M and M and N. M and N and M. N and M. You know N, you know N, you should know M. 对吗? Logical, right? You know N already, right? N is 2. Then you look at the formula, you must be able to deduce M is in group 2. Oh, so you give any one of them, magnesium, calcium, anything also can. Okay, can. Okay, any question first? We finish already. More concept revision. Okay, let's go on to acid bases. Another big topic. Any question you want to ask first before we cross over? Everything good? Thumbs up. Okay, can you pull out your acid bases and the notes we have given out to you? Okay, let me pull out also. Here, you have this page. Oh, have ah? Okay, okay. I'll give you an overview first. Then I'll tell you where are the key focus that you need to remember inside for each of these points. Actually, this page, I can basically cover the entire thing. Okay, entire portion. You don't have? Oh, okay, okay. Sure, sure, sure. Xiaomi $1. Clarice, are you there?
Yes.
Okay, can you all have this piece? 有没有？方玲 can not? 方玲 I cannot see you there. I can see your forehead. Your computer so low one. You can see me, oh. How you mount your computer? How come you cannot see the forehead? Like that? Is it like that? Is it? Okay, okay, I can see you already. Okay. Okay, can okay, shall we carry on? Okay, so let's take a look at acid bases. Okay, this chapter over here, you must remember is linked to mole concept. That's why we do mole concept first before we come to acid bases. Okay, so there are key reaction in acid that you must remember. Okay, so what are the key reactions? Okay, acid plus metal, acid plus carbonate, acid plus your base. Okay, so there are three of them you need to remember. Oh, so the equation involved are important because from there they will ask you to calculate certain concentration, calculate the mass of the product, blah blah blah. Okay, so all these topics are related. No context, there will be no more concept. Okay, the context come from where? Acid bases. This is one of the key areas they can extract all the context to test you. Okay, so first point, what are acid physical property and chemical property? I will go through all of you. Okay, so gone are the days. You all last time always learn about acid and base, acid sour, right? Physical property of your acid and the reaction of acid. This is very important. So you all put a star there. Okay, alkali and bases, same thing, the opposite of acid. Okay, you have learned that in your normal daily life, detergent, dishwashing powder. Okay, all these are alkali. Okay, property of alkali, soapy. Okay, so you touch soap before, you know how you feel, right? Then reaction of acid, alkaline, very important, especially there's one reaction that involves reacting with your ammonium salt that is used in a QA exam. Ammonium salt, when they react with alkaline, they give ammonia gas. In your syllabus, there's only one alkaline gas, which is ammonia. Turn red litmus paper blue. Okay, so that one I will talk about it later. pH scale and strength concentration. Later I will unpack for you the meaning of strength and concentration. Okay, then we look at our indicator, uses of pH, and then the key one is type of oxides. Okay, how many oxides you learn inside your syllabus? So the three of them, I put star. Oxides, there are four. Acidic oxide, basic oxide, neutral oxide, and amphoteric oxide. Okay, they love to test amphoteric oxide. So what are amphoteric oxide? Okay, later when we reach there, I will tell you. So put 3 star there. These are the 3 key areas inside your syllabus. Question will always be used surrounding all these 3 areas. Okay. Okay, now let's take a look at LO. These are all your LO for your syllabus. Okay, so I based on the LO cover everything with you. So you can see, LO, we have covered this. We talk about this later. Neutralization reaction, characteristic property with ammonium salt. Can you see? Base in reaction with ammonium salt. This one we must remember, ammonia gas is involved. State some use of acid and bases. And then we go on to differences of strength and concentration. What is a weak acid but yet diluted? What is a diluted acid but yet strong? What is a concentrated strong acid, and so on. Okay, so there are a few things that we will cover under strength and concentration. Okay, then pH scale, and how to test a hydrogen ion and the relative acidity using universal indicator and the pH scale. Okay, anything you're not familiar with, let's say your teacher taught you in school, right? Then you are not very sure one, you want me to unpack further for you, let me know. Because this is really preparing for your end exam maybe. Okay, and let's go on. So this is Other objective, acid and alkaline on universal indicator, litmus paper. Okay, the importance of controlling the pH. Then acidify oxide as acidic, basic, and ferritic neutral. Okay, so later I'll tell you an easy way to remember how to classify these four of them. Okay, right, so acid first. Are you familiar with the acid? Okay, acid ionizes in water, hydrogen to give you hydrogen ions when dissolved in water. So you can take this as to be a like form of reaction with water. Okay, so you can see whenever we test this topic with covalent bonding, ionic bonding, I'll be very surprised. Many times when I ask for dot and cross diagram for HCl, right, a lot of students will draw the ionic one, ionic compound. This is wrong, no? This is still a covalent compound. Okay, then you all may ask me, but then obviously this reaction give me H plus and Cl minus. Yes, you are right. But this is a dissociation reaction. Or dissociation means the acid itself, it has some form of reaction with water. Then it gives you ions. Don't confuse the idea of this compound. The nature of this compound is still covalent. Okay, so can you all please write big here? Three of you should not make this mistake. Okay, in exam you are asked for dot and cross diagram for HCl. Please remember it's covalent. I'm not worried about the other two, sulfuric acid and your nitric acid, because those are complex ion. Okay, complex ions you are not required to draw the dot and cross diagram. You know what's complex ion, right? Cl minus Cl minus over here, right? We call it a simple ion. One element only. Okay. Then NO3 minus, right? These are complex. Complex means it's made up of more than one atom. Okay, your syllabus does not require you to draw complex ion dot and cross diagram. Okay, so if you are tested during your exam for your in-house paper, right, that means your school exposed you to this kind of question, then you draw. Okay, well, of course, we also show you some during our practice. But your syllabus is very clear cut. Dot and cross diagram over here, right? You are only required to draw for your simple ion. Okay, unless you are taught in school, in-house, you have been asked to do that. Oh, where do you see acid? Or your vinegar, tomato juice, citric acid, or oranges, okay, vinegar, grapes. Okay, so take more. All these are very good for health. Okay. So you see, you should have a variety of fruits. Okay, a lot of people emphasize a lot on the vitamins and stuff like that. Okay, so but anyway, they contain other acids as well. Okay, so these are the common acids, especially grapes. They will contain your tartaric acid. Okay, citric acid is in oranges and lime. Then your vinegar, you know, that is your ethanoic acid. Okay, do not drink the one you find in the lab. The lab also called ethanoic acid. The concentration of the ethanoic acid and the one that you use in your home is totally different. That is industrial grade ethanoic acid. So you drink already, right? You know what will happen. Okay, likely you will find yourself sleeping in the toilet. Okay, because you will have diarrhea. Okay, so please don't do that. I know I have some students who try to do that in the past, then end up 3 days diarrhea. Okay, so ethanoic acid, the one in the lab is different from the one you use at home. Or you cannot add to your, what you eat now? What you're eating now? Shark fin soup. No more yet, because they say against shark, don't kill shark. Then you fish more also, fish more soup, something, you know, right? The vinegar you add in. All those are same as ethanoic acid. So next time you have it, you just ask your family member, can you pass me the bottle of ethanoic acid? Okay, then they know you study very hard for chemistry. Confirm. Okay, right. Common acid used in lab. Have you seen this symbol before? This is a symbol for corrosive, corrosion. You see this, don't touch it, please. Okay, so it's hydrochloric acid, sulfuric acid, and nitric acid. HCl, H2SO4, and HNO3. These are the three common formula for the acid in your lab. You must know. Okay, bench reagent are always found in front of you because they are used very commonly during QA. Your bench reagent in the practical lab, always in front of you, you'll see the acid. Okay, right, just to share with you, the dilution of acid is done very differently from the dilution of other substances. This acid, right, when you dilute, what do you think will happen? What do you think is the process that we do for dilution? Normally we add water to acid, right? Then we stir it to dilute it. We don't do that for acid. Acid is the other way around. Oh. This is water. This one is water. Right? You pour acid here to dilute. Okay, the reason is because, right, this H2SO4, I don't know whether you're seeing the concentrated one. Concentrated one, you see a lot of fumes coming out. It's very exothermic. If you place water the other way, right, put across here, you must remember, because I have a friend in the uni who do it wrongly, you know. Yeah, I tell you the story later. This is H2SO4. She was asked to dilute sulfuric acid. She go and pour water in. You know what happened? There is a layer trap over here that built up between the sulfuric acid and the water. The water is here, right? Here is all the fumes. So the suddenly the whole thing just exploded up. Okay, and then her face changed. Okay, 变脸. Okay, because acid burn. You all want to stay pretty forever, please remember what I put here. Dilution of acid is done the other way around. Pour acid into water, keep stirring. You do the wrong way, right? Sometimes the penalty is something that you got to live for the rest of your life. Yeah, my friend had to, I think, went for plastic surgery or what, but cannot get back the same face. The face keep changing. Of course, she has other options. That time she went plastic surgery, you can change to any Korean star face she want. Okay? But her original face was never retrieved. Okay, so if you major in chemistry, this is some of the danger. Okay, can just to help three of you understand, dilution of acid is done, must be done in the proper way. Okay, then ionization energy, ionization of acid. Okay, so this is how acid dissociate to form ions inside the water. The process is called ionization or dissociation. Okay, these two terms are used interchangeably. Okay, so remember, we are not interested in the Cl. You all know the name for these two, all these three? We are interested only in these three. Okay, the H plus ion. This is the main ion responsible for acidity. These three, they have a name called spectator. Oh, you know spectator ion, right? You know spectator, right? You don't know spectator? Sports day, you always say, come on, you can do it. Last 500 meter. Those are spectator. Okay, then I run until my whole tongue all sticking out already. I hear people shouting, okay, last 500 meter, you can do it, come on. All this. Okay, yeah. So in life, it's like that. If not the main, then you have to make sure that you are a good spectator, right? So if you're a spectator, you must cheer people up. Okay, so these are not responsible for your acidity. So always remember, okay, when you study chemistry, right, it's not just wow, you read on book. Okay, I know they dissociate to form ions. Everybody know that. Then when you ask, so what is the job of the chloride, sulfate, and the nitrate? Then you say they actually got no use. They are useless ion. They are not useless ion. They are spectator. Kind of. Imagine you all go for a sports day. All the runner running around, right? Then no spectator. How you all feel? Morale very low, right? So they have a job. No, they are there because when they when they combine back, right, they form back the acid. So if you have the H plus present, that is the main ion. You're right. That's responsible for acidity. You still need spectator ion. This is like that. All spectator ions so they are not involved in the acidity of the solution. Okay, and yeah, sorry. Yeah lah, it's like that. COVID-19, no spectator. Yeah, but now we're not COVID-19. Okay, okay. Physical property, sour taste. Okay, so remember, gone are the days before we actually become so advanced. Right? Can you imagine? I put one bottle of water, one glass clear solution on the table and tell you this is water. Then you drink it and then you say, hey, how come sour? Or it's acid. Okay, or you realize that it's not water, pure water. How do we know? Okay, so of course we have a lot of method to try to find out with the pH. Okay, but strong acid are corrosive. Okay, so your litmus paper can turn from blue to red. Okay, remember this keyword. Practical exam, please remember. 这个 circle highlight 来。Why Okay, acid is very funny. Without the solvent, water is useless. Without water, right, it cannot behave as an acid. Oh, it's very interesting because remember, right, without water, it is just a simple covalent compound. You need water to liberate the H plus. Without the H plus, the acid is useless. So if I tell you this white powder, which is 1 kg of HCl, if I want to open up and then pour over your head, then you say, well, I don't want, I will get acid burn. You won't get acid burn. Okay, because you are dry. You are dry, it wouldn't happen. But what happens if you come out from the shower? Then something will happen. Also, that's the difference. So you must understand if you remain dry, as in you don't have any moisture around, right? You touch acid, so-called powdered HCl is very safe. Okay, but once you actually come in contact with water, it's a different story. It will behave as an acid. Okay, so this word is very important. Okay, during practical exam, I noticed that many students when they answer that they confirm identity of a gas, acidic gas or compound or substance like this acidic, they always put down litmus paper turn from blue to red. They left out this word. Okay, you must remember the litmus paper must be wet before you can use it. If it's not wet, right, you cannot detect an acidic gas. Or the gas is not so smart. Your gas can penetrate through the litmus paper or go and wet it unless your gas is also wet. Also remember, pH is less than 7, dissolve in water to form solution that conduct electricity. Okay, so that is why, because you have ions present. Okay, so this is a salt definition. So these are common salts that we actually find in our lab, and you need to understand the formulas. You need to know common ones are your chloride, sulfate, and your nitrate. Okay, sorry, the wrong message. Who message is, what was it? Die. Why? Oh, no lah. You not say like that. Okay, the CV is going to be lifted soon. Okay, so these salt are different from the table salt. So please don't try. Or go and pick up your barium sulfate and then add to your 薯条, French fries. Okay, then you say, I want the salted French fries. Then you eat already, that's it. Again, what will happen? The toilet become your permanent bedroom. Or because you cannot leave the toilet bowl one. You keep diarrhea, but might as well sit down there. Sit down there and then 24 hours clear your whole system. I can tell you, if you experience food poisoning before, you know what I meant. Okay, so chemical property of acid, reaction with metal. Okay, so this is a reaction. Can you see how is it related to mole concept now? Knowing the reaction is one thing. So you will be asked to form the equation. Equation must be balanced. Okay, so on QA, you know this hydrogen gas is involved. Okay, so you can actually test for hydrogen gas. Okay, what are the exceptions for reaction with your acid? You must remember these three. Under reactivity series, you actually learn that copper, silver, and gold does not react with acid. Okay, and so these three you must remember. That's why you can see that they are used, like copper is used as a water piping, right? Then you'll say, wow, your vinegar, everything all throw inside the sink and then it's acidic, right? Then will the pipe actually corrode? The answer is no, because most of the water pipes that we have, that we see, they are being used in Singapore, right? Or a lot of countries, they are all made of copper. Okay, they are not made of silver and gold. So don't worry. If you are made of silver and gold, that's it. At night you see people start digging and remove your water pipe. So they are all made of cheap metal, copper. We choose copper for very simple reason. 3 of them don't react with acid. We choose the one that is the cheapest to manufacture water pipe. Okay, chemical property, pop sound. Can you take note, highlight this word, lighted spleen or burning spleen to the gas. Okay, so I like this word, lighted spleen. Okay, very different. You know what's a lighted spleen, right? Lighted spleen means on the spleen you see a fire. Okay, very important. Because the other test is for oxygen. Oxygen, you use a glowing spleen. This is not the same as glowing spleen. I write down here so you can jot down in your notes. Okay, the glowing spleen, right, is for what? Oxygen gas. Okay, glowing spleen. Okay, glowing spleen, what's the difference? Glowing spleen is just you just see a light there, just like you just see people who smoke, right? That is called a lighted cigarette. A lighter spirit, you see the end there, or your incense stick. You see people who do incense stick, right? That is called a glowing spleen. There's a different. Some students use glowing spleen during exam, try to test for hydrogen. I can tell you, 1,000 years also no pop sound. 1,000 years also will not get a pop sound. Then, of course, I cannot tell the person is wrong already. Hey, you make sure your spleen is lighted. Then you test. Cannot. Because as an examiner, I'm not supposed to review anything about the identity of the gas, right? By telling you to use a lighter spleen, I'm hinting to you there's hydrogen gas already. So we cannot do that. These two tests are very similar. So you need to remember glowing spleen, oxygen gas. Lighter spleen, hydrogen gas. So write down somewhere, it extinguished with the lighter spleen with a pop sound, very loud. Okay, this one is very interesting because every time we conduct, sure got test tube crack. Especially some of them, the guys in the class also shout very loud. You hear the pop sound, they shout and then they drop their test tube. Imagine they are going to protect the country. Protect the country, people also so scared of the pop sound, how to protect the country. Sometimes I also see my guy student, I also feel like crying. Okay. Also, especially the girls are braver. Girls, when you see pop sound, wow, so exciting. Okay? The boys are the one who drop the test tube. Every time I got to at least 10 test tube crack. All the boys will break my test tube. Okay, so remember when you do this test, hold it with a test tube holder, prepare, and then you bring the lighted spleen ready, standby. Okay, don't wait until the gas come out, right? You see magnesium ribbon go inside. You see effervescence coming out, right? Can you see this part here? You all know what is this? On your own slide, can you just add in or your notes? Effervescence. Okay, I want to clear up a misconception about this term. Effervescence refer to bubbles in water or in solution. You see bubbles inside the solution, you call it effervescence. Once it leaves the water, right, it's no longer called effervescence. What is it called? Gas. You don't say there's effervescence in the air. That is what? That sounds like an alien movie. If you see effervescence around you, it's time to run away. So you must remember the word effervescence. I don't know why a lot of students like to tell me effervescence causes the pop sound. That is not the effervescence that causes the pop sound. Can you see? Effervescence is to describe bubble in the water. It's the hydrogen gas coming out here that causes the pop sound. So when you're writing your answer, be very careful what you're writing. Okay? Sometimes you find it very funny. Then you write. Then you realize in the exam you get penalized because you see effervescence causes a pop sound. Hydrogen is present. Wrong idea. Effervescence cannot cause a pop sound. Only when they leave the surface of the liquid, the gas causes a pop sound. Question? I hope all these things that I emphasize to you a bit on your knowledge. Okay, chemical property. So that's why they are stored in glass instead of metal. Okay, so you store in metal, your acid will react with metal. Then you drink your metallic acid. So that's why you realize that nobody in the world will put vinegar in a metal bottle. Because some people will say, wow, metal very very classy. You put vinegar inside metal, you can sell 10 times the price. Okay, I think before you reach the supermarket, right, you see one hole coming out from the bottle. Your vinegar start leaking. Correct or not? Stupid one. The manufacturer never study chemistry, then will put inside metal bottle. No class one. Where got metal is more classy compared to glass. Okay, because that's a common misconception. Okay, you cannot do that for acid. Okay, so you cannot do that. All right, next, carbonate reaction, acid carbonate. Okay, this chapter is linked to another one under pollution. Remember acid rain? So this topic must study together with the topic on air. I'm trying to make link across topic. You know what I'm talking about, right? Air, you have this carbon dioxide dissolved in water to form acid rain. Remember that? Then we tell you acid will cause limestone to dissolve. That's why a lot of statue you see, especially the Italian one. Right? Have you seen Italian Rome statue? Oh, a lot of people say vandalism. It's not vandalism. It's because of acid rain. Over the 100 of years, our climate change, right? That's why you see all of them, the face disappear. But the troublesome part is that people still go and see, pay a lot of money, go inside to all this country, see all the statue, right? No eyes, no body, no nothing. Left only one pile of faceless person, okay, faceless statue. They pay a lot of money to go inside and watch. Okay, so they actually don't need or you can go online, Google and take the picture. When they were taken back in the early 19th century, you can still see the face. You all notice that? So before next time when you all go to all this country to want to see all these famous marble statue, they call it, all the Italy, Rome. Italy is ancient Rome actually. So you take a picture, go online to Google first, at least you can see the face. Then you go there, you see something that is totally faceless. Then you can know, this is how it look like. Then finally you decide actually don't need to travel so far to see a faceless thing. Google online can see it. You just search for the picture 1900s, early 1900s, you can still see. Okay, so this is a reaction. Balancing equation is your job. I always say to every candidate, it's your job. Okay, you don't balance it right, you cannot solve the mole question later. So be careful, balance it carefully. Reaction is carbonate plus acid will give you salt, carbon dioxide, and water. So you need to remember that. Formula for carbonate, I give it to you. I think by now you're quite good with it. Okay, here, test for carbon dioxide. What PPT form due to carbon dioxide, right? So again, when I was a young teacher, I always make a lot of assumptions. Set 1, set 2, you all learned before already, so should be okay. Okay, then when I asked a question during the exam, I got shocked. What is the YPPT? What is the YPPT here? Some more like that. What is the name of this YPPT? You must know, calcium carbonate, right? You go inside the liquid hydrochloric acid, your carbon dioxide come out, right? CO2 come out. This is what? Lime water. Lime water is calcium hydroxide. All right? Okay, remember, it's lime water, not lime juice. Okay? I don't know why exam I mark script, stress, exam stress or what? Test for carbon dioxide pass through lime juice. Lime juice, you go to the hawker center to buy. Okay, and it's more expensive than calcium hydroxide. Don't waste your lime juice on testing for carbon dioxide. Correct or not? So it's lime water. I know it's a joke, but very common problem. Lime water is lime juice. Lime water is lime water. Then some students are always very smart. Separate the two words. Lime water. What is lime water? Lime water, sengkam, right? Lime, you cut, right? Then you squeeze inside water. That is lime water. Those are two different things. So by separating the word, it's a different meaning altogether. Why I need to tell you this? Remember who marked your paper eventually. Not me, not your teacher. Who is it? Your Cambridge examiner, all the lao kok one. Close to 80 years old, 90 years old, all the great grandfather of chemistry. Once they see this, I tell you, right, their heart will nearly stop. Then they will penalize you for making their heart to stop suddenly. They'll say, oh, what is this? Then they will penalize you. So remember, lime water is calcium hydroxide. Are you all with me? I hope your teacher have taught you all this before. All these are common problem. Lime water, everybody knows it's lime water. What is it? Nobody knows. Calcium hydroxide. Can you write down by the side? This is calcium hydroxide formula. I write down the name. Calcium hydroxide, please, or aqueous calcium hydroxide is your lime water. Of course, if you tell me pass through aqueous calcium hydroxide, even better. You are very accurate to describe it as the chemical name. Calcium hydroxide. Now go back to my question. What is this YPPT? You must know, no? Because you see, YPPT, everybody spell out YPPT. The question asks, state the identity of the YPPT. What is it? You go back to the equation and ask yourself, carbon dioxide is an acid, correct? Plus calcium hydroxide over here. Isn't it a base? So what will acid and base do? They form a salt plus water, right? What is the name of the salt? Calcium carbonate. This is the white PPT. Oh, I hope you all learn something new today. If for the last 4 years you don't know what is the white PPT, today you know. Calcium carbonate is calcium carbonate forming inside the solution that is the white PPT. Oh, so if you are asked during your theory paper, state the identity of the white PPT, please don't write down here white PPT law. White PPT is what? White PPT law. There's no white PPT law. There's no law, okay? There's no law in Cambridge. You say white PPT law, that's it. Okay, it's calcium carbonate. I hope you all learned something new about this test. You all learn something new? Smash the chat button, yes. Exciting, right? Today you know something about this lime water test. Okay, the other thing, remember, 3 of you must remember, practical exam, don't be kiasu. No? I see people fill up this test tube to this level. You filled up to this level. You see the one in red? Until this level for your lime water, right? That means the understanding or dilution is very poor. You have so much of the lime water, you are passing in carbon dioxide, so little is forming. Can you see the white PPTs clearly? No. Instead, you see a lot of cloudiness. I can tell you during practical exam, if you do that, right, you cannot even tell whether the cloudiness is really calcium carbonate forming. Why you want to do that? Use as little as possible, okay? How much? I don't know whether your chemistry teacher taught you use your thumb. You see your thumb? Your thumb is like that, right? You see the part that bend? Thumb length. I draw a thumb here. No wonder they say my drawing very good. Can you see the thumb? Like that. Thumb length. If not, 1 cm. Estimate. Use as little as possible for calcium hydroxide. Use as little as possible, okay? The lesser of calcium hydroxide you use, right, you must think context or concentration. The moment carbon dioxide is being bubbled through, right, what will happen? The white PPT will form instantaneously because not enough calcium hydroxide. You make calcium hydroxide lesser, carbon dioxide go in, right, straight away, carbon dioxide will be very hungry to form calcium carbonate. You see a white PPT forming very fast. You see the white color come out already. Isn't it better? Why you want to use this level? You're not making the what? Ice popsicle. Ice cream or what? What you do? The what? The ice popsicle. You like to do one, right? Chemistry is a bit using common sense. Okay, not the more the merrier. The lesser the better. Okay, don't be kiasu. All this is, I hope I use this chapter also teach you all some practical skills. Okay, good. Clarice, you understand what I'm been talking?
Yes.
Yes, I cannot see your picture, so I need to ask whether you are with me. Can I understand? Practical, remember how much calcium hydroxide? Thumb length. Can you know your thumb, right? This is your thumb. Your thumb. Then you tell me my thumb is bigger than other people's thumb. Then you use half a thumb. Use until your fingernail length. Lesser the better. Okay, lesser the better. Next time practical, remember what I say. Don't be kiasu. Don't feed so much lime water here. As little as possible. The lesser you use, the better the result. Okay, Anna. Okay, next part. Chemical property. So this is your drink tablet. You throw inside the water, right? Then you see this fizzy drink, right? So again, like what I emphasize to you, it is solid acid and sodium carbonate present together. So when you add inside the water, then it dissociates. So the acid is not in the water. The acid is inside the tablet. Okay, you all drink this before, right? Eno or whatever, or you all throw inside, then you see the thing all come out. Then you all start drinking. Okay, carbon dioxide is then given off, which causes the fizz. You all drink this before, right? Sometimes you all need to drink like additional vitamin C or what. You all have this kind of tablet. You throw inside the water, you will form this kind of fizzy drink. Eno is one of them. Tablet size, tablet. Oh, this is the reaction behind it. All right, next one, be base is also known as neutralization. All right, so what are bases? Bases are metal oxide or metal hydroxide that react with acid to form a salt and water only. Okay, so now let me clear a misconception. Many students always have this misconception. What is the misconception? Okay, the misconception is that does it mean that the oxides will definitely form the hydroxide? What do I mean? Okay, example, does it mean that I have, let's say, zinc oxide will form zinc hydroxide? Iron oxide will form iron hydroxide? Depends. Depends. Why? Because in the first place, right, if your particular oxide cannot dissolve inside water, or you can no longer, it can not dissolve in water altogether, right, it cannot form the hydroxide. Also, you must understand that it doesn't mean that A lead to B. Okay, you have to see the nature of the metal. Okay, so over here you can see I have metal oxide and metal hydroxide, we know as neutralization, right? So we will see this reaction here. Can you see copper sulfate, copper oxide, and then copper sulfate? This one you must remember. Copper oxide over here is black color. Okay, you write down the color. This is blue. Copper sulfate, you all should be very familiar. Set 1, set 2, you all have this experiment called crystal growing. They always ask you to grow copper sulfate. You all remember not? Then you're super happy. You all see the crystal very big. You all clap your hand. Say, wow, my crystal very big. Wow, so happy. Wow, make my day. Then your teacher say, very good. You are very good. You know what's the trick behind that? You all were asked to live inside the lab, right? After you left the lab, your lab tech will add in a few more scoop of the copper sulfate. That's why the next day your copper sulfate becomes so nice. Okay, not your grow one. Okay, all those are mock up. Okay, right? Because you're young, we want to trap you, not trap you all. We want to make sure you choose chemistry and set 3. Also make you a bit happy. You see the crystal so big. The next day you'll come back and see, wow, the crystal so nice. I'm so good. So talented at growing crystal. I must major in chemistry. That was why I chose to be a chemist many years ago, because I also get tricked by this thing. Okay, right? So never mind. I tell you all, forgive your teacher. They are out of good intention. Okay, because we want to encourage you all. Imagine the next day you all come back, no crystal. Or you all empty the thing, you filter paper. I don't have anything. Then some people emotionally cannot take it, or break down, or then cry inside the lab. Very bad. Okay, I cannot stand people who cry because crystal cannot form. Okay, so you need to understand when we are doing this crystallization over here, right? You form your copper sulfate. That is a blue color copper sulfate. You can form this copper sulfate crystal only when you have a saturated solution. Okay, you write down by the side, saturated solution. Saturated solution means lessen the water. Make sure you know what's saturated, right? Saturated, you know what's the meaning, right? Okay, for example, your Milo, let's say 3 scoop to 50 cl of water, just nice chocolatey water, Milo. Then I tell you, add in 30 scoop, that becomes saturated. Or you cannot even stir the thing. That is called a saturated solution. I'm trying to use the context of Milo. Same thing. So you can heat and evaporate more water, and then you get a saturated solution. You leave it overnight, your nice crystal will form. That is your copper sulfate. Okay, let's go on to acidity. This is what I'm talking about. So don't be surprised. If it's dry, you are very safe. When it's wet, right, then you have to be careful. Okay, that's why your citric acid has no, without water, there's no reaction with magnesium. There's no reaction with your blue litmus paper. Nothing happened. You put there for 1,000 years also, nothing happened. Okay, right. But when the moment one drop of water go in, then it's a different story. The acid property will come out. So your litmus paper will change color. So this is what we are trying to emphasize to you, the importance of water in trying to liberate out your H+, right? Okay, so properties are used due to that. Preservation of food, ethanoic acid and citric acid are used for preservation of food. You're familiar with this part, right? Preservation of food, ethanoic acid, vinegar, citric acid. What I can think of, kimchi. You know kimchi, right? You know kimchi, right? Or kimchi, the Korean like to eat. It's just similar to what Singaporean like to eat the acar like that. Okay, they also use vinegar to go and preserve it, so they can keep for a long time, no? Or 10 years, I don't know lah, 10 years, maybe 5 years or 6 years. But they say the longer you keep, the better the flavor become. Also, acid is being used to do that. Okay, so this is for preservation of food and removal of rust. Okay, rust, you know what is it? Okay, another thing, so every lesson I need to drop things so you all can learn something new. Rust is iron 3 oxide. 2 here and O3 dot XH2O. Oh, this one is rust. Okay, can you write down somewhere? Hydrated iron 3 oxide, that is rust. Okay, I know that some of your teacher tell you iron 3 oxide is rust. That is not correct technically, because water and oxygen is needed for rusting. So the compound that you see, you know, rusted, your chair, okay, when CB is open, you go back to your school, you can find rust. You know where not? Your chair, the chair in the classroom, all the legs are confirmed rusted. Because when you sit too long, your sweat come out. Your sweat come out, then come in contact with the chair. The chair, the legs, they start rusting. Okay, so confirm the first part that start rusting for the classroom chair, right, is near the seat because of the sweat coming out from the student body. Very hot. I know the classrooms are very hot. Okay, right. That is your iron 3 oxide. Okay, so how to remove it? You can actually use hydrochloric acid, sulfuric acid to dissolve the base. It's actually a base, iron 3 oxide. And okay, now let's take a look at the reaction of acid with metal. Okay, can you write down in the 3 boxes what you have learned so far? So we cover 3 of them already. We start with which one? Acid plus base, salt plus water. Okay, you'll do this one on top. Acid plus metal, salt plus hydrogen gas. Then carbonate, carbon dioxide, salt first, carbon dioxide, and water. Okay, and reaction of acid. Okay, let's go on. Bases. Okay, so definition of bases, they are metal oxide or metal hydroxide that react with acid to form salt and water. I think you all should know by now, all the oxide behind in front is metal. They are all called bases. Okay, now we come to this special class. Definition of alkaline. Bases which are soluble in water, right, is a base that ionize dissociate into hydroxide when dissolved in water. So you have sodium hydroxide and aqueous ammonia. All right, so remember, we can say that all alkaline are bases, but not all bases are alkaline. I repeat again, all alkaline are bases, but not all bases are alkaline. Is it a bit confusing? No? So similarly, I tell you, Superman is a man, but not all men are Superman. You understand that, right? Because Superman can fly, the rest of us cannot fly. So we are normal men. The one who can fly is Superman. Just remember this idea, then you translate back to bases and alkaline. So in general, we can call all of them bases. But those that dissolve in water, we give them a special name, alkaline. Also, among 1,000 men, I can tell, these are all men. Then one of them stand out, right? Wear the underwear outside one. Oh, Superman. This is Superman. So I will introduce to the world Superman. Can I remember that? That's an easy way to remember the difference between bases and your alkaline. The one that is special, can dissolve in water, we call it alkaline. So don't get too worried about these two terms. Even though interchangeably, right, usually they are being used in exam. Okay, but remember, bases, right, can be insoluble in water. Those which are not soluble in water, right, we call them, we just retain the term base. We don't call them alkaline. So the other misconception is that it doesn't mean that hydroxide are all alkaline. No. Don't think hydroxide must be alkaline. Some hydroxide are still bases. They don't dissolve in water. Who will dissolve in water? Alkaline. Remember these 3 of them. S, P, and A. Spa. Who are spa? Sodium. You write down your notes. Sodium, Alkali are those which are sodium, potassium, and ammonia. These three are the common ones. Okay, SPA, SPA. So when I tell you, I want the spa. So you try to remember like spa is where you see people add the salt, right? Those bath salt inside the water to create the bubbling thing, and then people go inside to relax, right? Not your idea of spa. So remember, spa are all the alkaline salt. Alkalines are all the spa. Okay, the spa salt, sodium, potassium, and ammonium. Huh? Okay, so difference between bases, can you see over here? All the bases all outside, alkaline in the center. Okay, so from what your math teacher teach you, it's called a subset of base, but it's not base alone. It can be called a base, but then the special name given to it is alkaline. Okay, example alkaline, this one are the common ones that used in the lab. Lime water. So the name is here. Remember, or please remember this lime water name is calcium hydroxide. Okay, so which are the common ones? Group 1 metal hydroxide oxides are soluble base. So very clear cut. Your sodium, potassium are in group 1. Then ammonium salt are all soluble in water. Okay, so that's how we actually derive this example. Okay, so quick check. Okay, can you classify them? Right, we finish this one up for the day. Give you 1 minute to try. Based on what I tell you, spa. If it's not spa, then don't want. Who are the spa? You all want to know a secret? You all want to know a secret as you attempt this question? You see, ready? I show you on the screen. Ta-da! You see what? I have 2 cows. They look alike. Yeah. So interesting. Yeah. You all thought I'm drinking from the same cup, right? Then how come my cup, the water cannot finish on that bottomless cup like that? Because there are 2 cups. Huh? I bet you didn't suspect, right? There are 2 cups. Okay. Can answer? Yes. What the chat? Okay, Pinky. Okay, Pinky. Pinky. Yeah, Ken also Pinky. Pinky, is it Pinky? I don't know about Pinky, but we all spa to remember. Okay, so this is how you can see alkaline hydroxide confirm soluble if it's SP and A. Okay, so you have alkaline here, you have alkaline here. Then your zinc oxide is a base. Okay, magnesium oxide is a base. Remember here, this is a very good example. It's still a base. Doesn't mean that hydroxide is alkaline. Because I know that you're used in the lab, lime water is calcium hydroxide, then your sodium hydroxide, potassium hydroxide, and so on. Okay, so generally, when we ask this question, even for A-level student, right, they say, of course, hydroxides are all alkaline. That's not true. Only the hydroxides which are soluble in water, then we call them alkaline. So don't go away with the wrong thinking. Hydroxides are alkaline. This question here is a very good example why hydroxides are not alkaline. They are bases. Most of them are bases except for the spa. The spa ones, sodium hydroxide and potassium hydroxide. Understand? Okay, let's carry on. Still have time, right? Okay, ionization. Okay, let me cover this part first. Ionization of water to form hydroxide. So they form hydroxide. Remember, just now I told you what's the name for Na plus and K plus? 这两个 spectator. We are not interested in them when we come to discussion on basicity. How they function as a base, we are interested in the hydroxide. This is the main ion. Okay, so remember that every time when you discuss about whether acid function as an acid or a base function as a base, right, focus on hydroxides and the H plus accordingly. All right. Okay, this is a physical property. Okay, so I will we end here after I finish this. Bitter taste, soapy to the touch, strong alkali and corrosive. Okay, don't underestimate alkali. They can be dangerous. Okay, so after that you can also dissolve in water to form solution that conduct electricity, and is a reverse of acid. Litmus paper turn from red to blue. Okay, keyword moist litmus paper. Okay, if it's not moisted, if it's not, if it's dry, it cannot work. pH more than 7. Oh, 10. So this is the one. Okay. And any problem before we round up? Okay, next week we can carry on with the practice question already. Also, you all can try the practice question first, and then after I finish the notes, we straight away go inside to try the practice question. Okay. And any question? Charmaine, okay? Clarice, Fang Ling, I hope you all learned something new, especially the test for hydrogen gas, what to look out for carbon dioxide, what is the YPPT, and then the property, nature of acid, and so on. Okay, so far so good. Or anything that you burning question in within you about this chapter, feel free to bring out, or we can actually open up for discussion, because I won't know which are the area that you all will need more help in. Okay, so generally these are the key points that we try to cover inside this chapter. All right, okay, okay. So I'll see you all next Sunday. Can good. Happy? Bye bye. 再见. Next class is coming in.
Bye
Okay, bye.
bye.
Thank you. Take care.